Hello everyone! So in this video we're going to be doing 2019 AP Calculus AB to question number 6. 2019 AP Calculus AB question number 6. Okay, and every time the college board people, they always amaze me at how unique these questions can be, and this one's a good one. Okay, so functions f, g, and h are twice differentiable functions with g of 2 equals h of 2 equals 4. The line y equals 4 plus 2/3 x minus 2 is tangent to both the graph of g at x equals 2 and the graph of h equals 2. Okay. So we know that the line is tangent to both the graph of g at x equals 2 and the graph of h at x equals 2. And they're asking us to find h prime of 2. Now, h prime of 2, if we were to look at this equation, the tangent line, the slope of it is 2/3. Okay, just like if you would convert it to slope-intercept form, okay, then you would easily get a slope of 2/3. So that part was pretty easy. Part B. Let a be the function given by a of x equals 3x cubed h of x. Write an expression for a prime of 2 of a prime of x. Find a prime of 2. So we're given that a of x equals 3x cubed h of x. So what we can do is just apply the product rule here. A prime of x equals f prime g plus g prime f. That is our expression over here. Now, a prime of 2 equals 9 times 2 squared. That's 36. H of 2 plus 3 times 2 cubed, it's 8. So we have 24, h prime of 2. We know h prime of 2 from part A, it's 2/3. So what we can do, h of 2 is 4. That's given to us up here. Okay, so 36 h of 2 equals 36 times 4. That is equal to 144 plus 24 times 2/3. So 2/3 of 24 is 16. So 144 plus 16 is 160. There we go. So a slope of 160. So that's a prime of 2. So part C. The function h satisfies h of x equals x squared minus 4 over 1 minus f of x cubed for x is not equal to 2. Okay, so x can't equal 2 here. It is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule or L'Hopital's rule. Use the limit of as x approaches 2 of h of x to find f of 2 and f prime of 2. Okay, so it's shown that it can be evaluated using L'Hopital's rule. So what does L'Hopital's rule say? So that means if h of x equals f of x over g of x, and if the limit as x approaches something of h of x is equal to 0 over 0 or infinity over infinity, It is also equal to the limit as x approaches that same value, a, of f prime of x over g prime of x. And now it makes it a lot easier, okay? So as x approaches 2, if we try direct substitution, we get h of x, okay? The limit as x approaches 2 of x squared minus 4 over 1 minus f of x cubed, that equals 0 over 1 minus f of 2 cubed. Yes? We're just directly substituting. And now they give us that you can evaluate the limit using L'Hopital's rule, so this denominator must be equal to 0, because these are the only two conditions in which you can use L'Hopital's rule. So what we have to do is solve this for 0. 1 minus f of 2 cubed equals 0. Okay, and what we get is f of 2 equals 1. Now, f of 2 equals 1. So f prime of 2, so now what happens? If we take the derivative of both the numerator and the denominator and find the limit of that, as x approaches 2, what we're going to be doing is just take the derivative of this, and we get 2x over 1 minus, actually not 1 minus, negative 3 times f of x cubed, not cubed, squared f prime of x. Okay, you're just using the chain rule over here. Okay, so in the bottom we use the chain rule, on the top we just use the power rule. So as x approaches 2, we get 4 over negative 3 f of 2 squared f prime of 2. Now, this can be solved, okay? And we know this exists because, we know this has to equal 4 because we're given that h of 2 equals 4. So this limit has to equal 4. That means that this quotient must equal 1. So that this quotient must equal 1, we just found that f of 2 equals 1. So we have negative 3 f prime of 2 equals 1. And divide by 3 on both sides, we get f prime of 2 equals negative 1/3. Negative 1/3. Okay? Now part D. It is known that g of x is less than or equal to h of x, for 1 is less than x is less than 3. Let k be a function. Okay, so g of x is less than h of x, or 1 is less than x less than 3. Let k be a function satisfying g of x is less than or equal to k of x is less than or equal to h of x, for 1 is less than x less than 3. Is k continuous at x equals 2? Is k continuous? Well, now what we have to do is visualize what this would look like. Okay? So if I were to visualize this, this is 1, this is 3, this is 2. So this is g. This is G. So this is G. I'm just redrawing it because this will be later, important later. This is H. And there's a reason why I'm drawing it this way, okay? Because we know they have the exact same slope and tangent to the exact same line at x equals 2. So they're literally touching each other. You're literally touching each other. And if k is in between them, it's literally sandwiched in between them. It's literally sandwiched in between them. Because H, this is H, this is G, this is K. Because H and G are tangents to the same line, they're touching each other. K is literally squeezing in between them. The reason they're squeezing is because you use the squeeze theorem. Okay, use the squeeze theorem. So if G and H are the same value with the same, and they're just literally touching each other, okay? So if this is true, then the limit as x approaches 2 from both sides of k of x equals the limit as x approaches 2 of G, as well as the limit as x approaches 2 of H. So we know that this limit is equal to 4. That is equal to 4. So the limit exists, and it's the same from the left and right. Okay, it's the exact same from the left and the right. And because it's just squeezing in between, k of 2 should equal 4 as well. It's literally sandwiched in between. So yes, k is continuous. And we're done. We just solved this for your response question. If you have any questions, please comment below. Thanks for watching.